Hello ladies and gentlemen, my name is Mr. EDK and today I'm going to teach you guys how to write the equation to an exponential relationship from a word problem. Before we do that, let's refresh our memory on what the different parts and components of a exponential relationship are. We have f of x equals a times b to the x power. These are the parts that we see in these exponential relationships. The a value is the initial amount. So if we were to open up a bank account somewhere, the amount of money that we were to put into that account would be our initial amount. The b is our factor of change. And using my bank account example, the factor of change is the interest that it gains every month. How do we find this information? Well, the initial amount is normally given to us in the word problem by telling us we start with this, so we're looking for the word start. We're looking for the words at the beginning. These are a couple key words that we are searching for. For the factor of change, we're looking for a couple keywords. A couple of those is just, as it said, factor of blank. So if I said something like, my tree grew at a factor of 1.2 a year, what that means is that 1.2 is what I would be multiplying by over and over again. Now, it's not always 1.2. This is going to be some other representation. So this value, this unknown location would become my b. Sometimes I'm going to see the words double. When you see the word double, this means multiply by 2. If you see the word triple, you're going to be multiplying by 3. If you see the word halved, you're going to be multiplying by 1/2. So those are some of the key words. There's a special situation that you'll also see. You're going to look for this phrase, increases by blank percent. Now, what does that mean? Well, when we increase by a certain percentage, we are going to do 1 plus, we are going to be multiplying by 1 plus that percent written in decimal form. I'm going to take this percent and write it as a decimal. The opposite of this would be decreases by blank percent. When we decrease, we are multiplying by 1 minus that percent in decimal form. So these are a couple of the key phrases we're looking for in order to determine what we are going to multiply by over and over again. Why do we revolve around 1 here on the increasing and decreasing? Well, as a quick reminder, if we did a times 1, this would equal a. If we multiplied by a times 1 plus some unknown value, this would be greater than a. An example would be 10 times 1.5 is equal to 15, and 15 is greater than 10. If 10 was my a value, then by multiplying this together, this multiplied together, which equals 15, is greater than what I started off with. On the other hand, if I did a times 1 minus some number, this would be less than a. Okay, so that's being decreased. It's getting smaller. This right here is why when we increase, we take 1 plus that percentage. If we're decreasing by a percentage, we're going to do 1 minus that percentage. So let's just see an example of how to find the factor of change. If I had a problem that looked like this, and I wanted to know what is the factor of change. The factor of change in this situation is going to be, well, let's read it. The population of a town is decreasing at a rate of 1.5% per year. So every year they're losing 1.5% of their population. Well, what is that factor of change then? The factor of change is going to be 1 minus 0.015. Why 0.015? Well, let me scoot this up really quickly. 1.5% literally means 1.5 per 100%, which written as a decimal is 0.015. Verify this using a calculator if you want, but this is what you get. So we end up with 1 minus 0.015, which then equals 0.985. So my factor of change is 0.985. That's how I use a word problem to find my factor of change. Now I'm going to show you a word problem that has all the components you need in order to write the equation. Here I have a word problem, and I've edited some of the information out because I don't need it, but you'll read it. It says, I save my money in a bank account that pays me 3% interest on the money in the account at the end of each month. So really quickly, 3%, I'm just going to make myself a quick note, 3% written as a decimal is 0.03. So that's going to be important information because it's percentage. I started the account with $50. Oops, that's a really important piece of information. I started my account with $50 I got at my birthday. Use an equation to create a mathematical model of the amount of money I will save in the account after M months. So really quickly, it pays me 3% interest. So that means I'm going to increase. When I read this, it doesn't use the word increase, but it implies it by paying me. So this 0.03 is my increase. So we're dealing with an increase percentage. So really quickly, my initial amount, which is A, this is going to equal $50. My factor of change is going to be 1 plus 0.03. Again, I'm not using the percent in its percentage form, I'm using the percent in its decimal form, and I'm adding it to the number 1 because I'm increasing. We add when we increase. So what is going to be my equation? Well, my equation looks like this. F of x equals a times b to the x value. My initial amount was 50, and I'm going to multiply that by 1.03 raised to the x value. And so that would be my final answer. Taking a look at a different situation, this one, on the other hand, let's go ahead and read through it. It says, at the end of the summer, I decide to drain. Ooh, that's a key word, drain. When I see the word drain, I'm thinking of loss, losing, draining something. Draining what? The 1,500 gallon swimming pool. That right there is where we started. We started with 1,500 gallons. I noticed that it drains faster when there is more water in the pool. That was interesting to me, so I decided to measure the rate at which it drains. I found that 3% was draining out of the pool every minute. Use an equation to create a mathematical model of the gallons of water in the pool at t minutes. Again, here's my 3%. 3% is going to be written as 0.03 in decimal format. I started at 1,500 gallons, and my factor of change is going to be 1 minus that 0.03, which equals 0.97. So I'm losing that 3%, which gives me that 0.97. Therefore, my equation, which is going to be written the exact same way, a times b to the x power, I'm going to start with a, which is 1,500. I'm going to multiply that to 0.97 raised to the t power. And this would be my final answer, f of x equals. So the difference between increasing and decreasing has to do with how I add or subtract around 1. Okay, so 1 is always going to be 1 plus something. That's going to be an increase value. 1 minus something is going to be a decrease value. I always want to know my initial value. Now, I can always go about this the other way. If I looked at this equation and said, hey, this has to do with draining a pool, what could this 1,500 represent? This 1,500 represents where I started. I always started here, so I always know that this is where I started. This is a starting measurement of some sort. Sometimes I don't know what that measurement is. Other times I do. In most word problems, they'll tell us what that measurement is. What are we measuring? So here's another example. Medicine taken by a patient breaks down in the patient's bloodstream and dissipates out of the patient's system. Suppose a dose of 60 milligrams, okay, so that sounds like an initial amount. 60 milligrams is where we started. So really quickly, A equals 60 milligrams of anti-parasite medicine is given to a dog, and the medicine breaks down such that 20% of the medicine becomes ineffective every hour. So that means that 20% is not being effective anymore. How much of the 60 milligram dose is still active in the dog's bloodstream after n hours? So my percentage is 20%, so 20% written as a decimal is 0.20, right? There's that 20 hundredths, okay, or 2/10. And so what's my b value? Well, it's a losing, so it's always going to be 1 plus or minus something. Well, we're losing, it's breaking down, minus 0.2, which then equals 0.8. And so my equation will become 60 times 0.8 raised to the n, because we're using n hours. So we have a loss of 0.2, giving me my 0.8. If I have this, if I started with my equation on the other hand, I can look at this and say, hey, this was some initial starting measurement. And looking back at the word problem, that measurement was in milligrams. Why 0.8? Well, I look at that and I say, oh, that was a 20% loss of something, right? We're left with 80%. At the end, every hour, we have 80% of the medicine working, but 20% was lost. And that, ladies and gentlemen, is how you use a word problem to generate a exponential relationship equation. We find the initial amount, and then we use the percentage of increase or decrease to then add or subtract from 1 as our factor of change. I hope this video helps you. You take care, stay healthy, and stay safe. See you next time.